Let's start. Bill, floor is yours.
Brilliant. Okay. Thank you for having me today. I'm going to try to do my best to keep this down to an hour and a half. The goal of this talk is to present to you as much of the new syntax that's coming with generics and the current draft document that is out there. I will do my best to take questions around the syntax during the talk. And then at the end, I want to make sure that there's room for those of you who want to discuss your comments, opinions, questions I might throw at you as well. We have time for all of that. But again, the real goal for me right now is to allow as many people as possible who don't have time to read the draft and or play with it to at least experience what the draft is. All right, I've added 3 links into the chat window. Yeah, I made sure it was for everyone. So I've got the GitHub training repo, which I'm going to show in a second. I've got the actual link to the draft document. And then third, I've got a survey from the Go team. And after the talk or sometime after the talk, it would be really great for you to be able to fill out the survey. It gives the Go team your direct feedback on everything you're going to see today and the generics draft proposal in general. So it's your opportunity to actually provide direct feedback to the team. And we're going to need that direct feedback if we're going to realize generics in Go maybe by the end of next year. If we're lucky, the August release, I think, is the earliest we could expect this to be released. Okay, with that being said, let me share my screen here. And what you're seeing right now is the training repo, and I'm inside the generics section. So I do have 11 examples here. We will not have time to go through all of those. We will get through the first 6. The first 6 really teach the base new syntax for generics. The other 5 are for you to look at and explore, and and they provide a little bit more practicality around where generics could be used. I'll do my best to keep things practical, however, but that's for you to look at and you can comment on as well. The README has all the links you need as well. You've got links for the draft here. You've got links to the Go playground. The language team keeps that playground up to date. The Go playground runs the transpiler that I'm going to be running locally in my terminal. It gives you an opportunity to work with the new syntax. Also, I've stolen from the draft the high-level overview of what this currently draft is suggesting that will be supported for the first release of generics. It's not going to be everything. It's going to be the bare minimum we need to make generics a viable option for a certain class of problems that are more difficult to solve today in Go. So you can read that list. I'm not going to read it. Also, a list of omissions, the current things that are not expected to be in the first release. Notice I'm saying first release. This to me is probably a 3-year project from the time we get to the first release till we're kind of done saying this is what generics are going to look like in Go. So just because you see something on the omissions list, don't think that it's not necessarily going to get in, even the first release, though that is probably highly doubtful unless somebody comes up with an incredible reason why it really needs to be there day one. But these are things that could potentially show up in the next 3 years as well. Also, got some links for extra reading, and if you want to install the Go tooling locally, I've got instructions here on how to do it. These are the instructions that I've used on my local computer. And you can see here, if I do Go version, that I'm running a build of Go's latest source code as of 3 days ago, using the Go branch. All right, so I'm going to be running these things locally on my machine. You'll see that. All right. Again, all of this stuff you can copy and paste into the playground as well. All right. With all that said, and time being of the essence, I want to really jump into it. again, the goal for me is to teach you as much of the new syntax that's out there, give you an opportunity to look at it, give me an opportunity here to kind of share it with you, and then we can have questions on syntax, comments, and all that. So let's start with the very basics here of the syntax. Now, if the font also is not large enough, somebody needs to just interrupt me and let me know. Actually, I could probably even go a little bit bigger anyway. Let's do that. Okay. Let's say for right now, I wanted to write a function that could take a slice of integers and then range over those integers in some, a linear traversal, displaying each integer out one at a time. So if you look at line 13 here, I've got a function called print numbers. It takes that slice of int, and it takes about 5 lines of code to display that with the header all on one line. And I would argue that Go developers of all levels, even if you've only been working with the language maybe a few weeks, I think everybody can consume and read this code, right? This is code that we could all, I'd say, read and be able to maintain. But this function is, I will call, our concrete version of a print numbers function. It can only work with integers, and there it is. Now, what if I wanted to also be able to do the same thing with strings? Well, I now am writing a second function called print strings. We're changing the slice of int to a slice of string, but the 5 lines of code are essentially the same. And ranging over integers isn't really different than ranging over strings, other than the variable names I'm changing for context. And print is able to display those ints and those strings. So there isn't really a lot of change in these two functions. But I wanted to print strings instead of integers, so I have to write a new function. Now, what if I wanted just a single function to be able to print both integers and strings? Well, in the current language today, we do have the ability to do that through the use of an empty interface and through the use of type assertions. So look at my print assert function. It now says that I will accept a slice of any type, technically data of any type, right? Because that's what the interface does. It doesn't really put a constraint on anything related to the data that will be passed through this function. But then we have to perform the type assertion. And on the switch, I'm doing a generic type assertion to then validate on each case statement what was a slice of integers passed in or a slice of string. And then I have the for loop accordingly for that data. And even this code is, again, is pretty much the same. Essentially, what I've done here is I've converted the two functions that I had into case statements, and then was able to write a single function to be able to print this slice of int or string. Now, this function is more flexible, but it's still really not a generic function. If I wanted to suddenly print a slice of floats, I'd have to add another case, just like before I had to write another function. So the empty interface gave us the ability to have a single function, but the type assertions are still locking us in to having to write more code for the different types of slices we may want to support. So is there a way today at all to write a generic function in Go? And the answer is yes, actually there is, thanks to a package in the standard library called reflection. Now, you can see our print reflect function is going to continue to use the empty interface because we have to be able to accept data of any type, in this case, a slice of any type. But it's the reflect package now that lets us write some generic code. We use the value of function out of the reflect package to get this reflect value that we can then leverage and ask questions about the concrete data, like, is this a slice at all? And if it's not, we do have some error handling to do here, which I'm not doing, but that would change the kind of function signature. So I've just kind of left it as a return, but not perfect. But if there is a slice inside of the interface value v being passed in, Well, I can do a traversal across that regardless of the data that this is a slice of, whether it's an int or string or float. I can use these reflection methods like index and interface to get to the concrete data. Now, I am getting lucky that print is technically a generic function as well. When you think about it, print is using the reflection package and therefore, again, is applying generics via reflection, which allows me to have that one single line on line 63 to output whatever value of whatever type this slice is. Now, I can argue that we have generics and go, I've written a generic function. But when we look at this function, we went 5 lines of code, 1, 2, 3, 4, 5, 6, 7, 8, to 10. Like I've doubled the amount of code that we needed in order for this to work. And I can't make the argument anymore that Go developers of any level could come in and read and maintain this code. In fact, I couldn't write this code out of the box. I needed to go into some documentation and remember what the APIs did. And if it's been a while since I've looked at it, maybe some of it's obvious, but it isn't necessarily obvious to everyone, especially this call to the interface method. So one could argue we have generics already thanks to the reflect package, but the code we have to write gets more complex, harder to read, and more difficult to maintain. Ideally, what would be nice, ideally, would be to be able to write a generic function using these 5 lines of code instead of the 10 lines of code I had with the reflect package. In other words, we know that this code is consumable by most Go developers at every level. The only difference between these lines of code is that I wanted ints and strings, but if that could be generic and we could leverage the same code, then we could write a generic function that can be consumed by just about everyone again. And this is where the current draft is trying to take us. One of these cases where can we add a generics implementation in cases where we're using the empty interface and maybe reflection, where we could potentially maintain those concrete implementations and make those generic. I love reflection. It's an amazing tool, and generics isn't going to replace everything we do with reflection. Model validation and those types of things, and encoding and decoding. I think reflection still has this huge place in the language, but I think there's ways we can simplify existing code today where the empty interface shows up. Now let's take a look at, from the current draft's syntax perspective, what a generic function would look like. And you can see, before we break this down, the same 5 lines of code that I had for that slice of int and that slice of string. Again, we're getting somewhat lucky that print is a generic function using generics, but minus that for a second. Now, there's something I want to do to initially look at this. I'm going to remove this piece of the syntax out just quickly. And when we look at this function I've written called print generic, you can see that I'm using an identifier named t, in this case, to try to represent that this is a slice of t, a slice of some type to be determined at compile time. And this is where I want to focus a little attention. You see, the problem right now when it comes to writing a generic function is we've got to somehow tell the compiler that this identifier, in this case t, is not going to be defined by me, but it has to be defined somehow at compile time. In other words, with the syntax the way it is right now, the compiler is assuming that I'm going to be doing this or something like this before I ever try to build or compile this program. The current syntax here is suggesting that t will be defined by me before I ask you to build. But that's not the case. The case here is really that I want to tell the compiler, or I need a way of telling the compiler, that I am not going to be defining t before you go and go ahead and try to build and compile this program. I need you to figure out what T is. So unfortunately, this syntax right here isn't going to work. This is what we have today. And so one option that we have, or at least one option that is currently implemented by the draft, is the use of these square brackets in between the function name and the parameter list, and using this keyword type, and then some identifier that you want to use for that generic type. In other words, what we're really doing here, and what I want you to kind of remember and focus as I continue to show you more code, is we're trying to tell the compiler that this identifier, this type named T, is not going to be defined by me, but it has to be defined or identified by you at the time that we go and build or compile this program. And this is right now how we're going to do that. This is the new syntax here. This is telling the compiler that T will be defined by you at compile time. Okay, and now I can define a function that takes a slice of some type T to be determined at compile time, and then I can write code as if T is defined already, whether it's the int or the string or the float. And we get back to our concrete implementations of code that many of us, if not most of us, can consume, read, and maintain, and not have to go down the path of the reflection package in cases where I think the reflection package maybe was a little overkill to solve this problem, thanks to the ability to have these now generic types. And the square brackets giving us a better visual on that. Now, the original draft up to a couple of weeks ago was still using parentheses here, and that is still an option for you to play with. The type list, or like the generic type list, can be done with a set of parentheses or the square brackets. I'm going to be using throughout this talk the square brackets, the new operators. Now, I think they do help with readability above the parentheses, and that's what I'm going to be using. But don't, just because I'm using the square brackets, don't feel like you have to. Experiment with both parentheses and square brackets as you start. Okay, I want to build and run this program and show you what's happening here as well. So here's the main function. And you can see I can construct that slice of integers or that slice of strings. And the idea is I can pass that slice as is across all four of the functions that I've implemented: the concrete, the empty interface assert, the empty interface reflect, and the generic. And if I head over to the terminal window and we go into O1, I can build and run this code. Now, like I said, I'm running that latest version of Go off of source code. And the go command is the transpiler. This isn't, or this hasn't been implemented yet in Go. What they've implemented is a tool that can transpile this source code that I've written using, if you haven't noticed, a go-to extension into a Go file that can be currently built, compiled, and built by the compiler. So what I'm going to do now is tell the compiler here to transpile this into a Go file, build and run it. And there we are. We see that our generic functions are now working, both with that slice of integers and the slice of floats. But remember, I get back to the idea that if I wanted to operate against floating point numbers right now, well, either I have to now write a new version called maybe print float, or I'd have to add a new case to the assert. But the fact that the reflect function and our generic functions are generic, right? I don't have to do any more coding. I can use reflect, or I can tell the compiler, here, why don't you write a function called print generic that leverages now slices of floats. If I do this, and you can see I've got some sort of bug here, beautiful. That should work. We could look very quickly on line 92 to see what I did wrong, and I forgot to change the type out, because why would I want to do that? And now it works, right? we can see here that we're now able to leverage floating point numbers without writing any more code, without writing any more functions, no more cases. Now, one thing I want to share with you, and I think it's an important part of the spec, is that the idea here is that Go is trying to identify what type T is going to be at compile time. And we're getting lucky right now, maybe not lucky, but we're taking benefits from the compiler that it can infer what type T will be by the input. It sees that this is a slice of int, so int ends up being T. Slice of float, float 64 becomes T, strings become T. But I want you to realize that you could, if it's necessary, be explicit about what type T is going to be. That this does represent a list, a parameter list of types. There are times where the compiler can infer the type. There may be times, depending on what you're doing, where the compiler can't. And so we can tell the compiler explicitly at compile time that T is going to be an int, T is going to be a float 64, T will be a string in the invocation of this call right here on these different lines. So we can do that. We can call that the longhand. So I'm going to make a small argument right now that if we have to explicitly pass the type into the generic function like this, where T can't be inferred at compile time, I'm going to make a small code smell argument that maybe what we're doing is more complex than it needs to be, or maybe we're forcing generics in a place where we shouldn't. It's been my small experience so far, though. If you look at the hash example in this training repo, you'll see where I have to be explicit on the types. So I'm not saying that anytime you do it, it's unnecessarily smell, but I think initially for me, when I've had to explicitly pass the type in these particular cases for the function, and I've sent that code to the language team, they have always found a way to do it without the explicit type information on the call. So it's something that I'm studying, and if you can decide to start working and playing with the syntax on code that you've written for your projects or at work, just think about when that has to happen. But you've seen that you can be explicit with T. Though what we really want is the compiler to infer the type. So calling this function is no different than calling the rest. Okay. So I've provided at this point this just initial kind of view of the generic syntax for writing these functions here. Now, as I walk through a lot of this, in between, I will look for questions. I don't necessarily ready to deal with comments, okay? But if you have very specific questions, then I'd be happy to answer them as we go so you don't necessarily get lost here. Now, the questions that I see are ones I want to save for later, okay? Later, so that's fair. All right, let me move on. So we've seen some syntax. We now understand what this is for. This exists because we have to tell the compiler that T will not be defined by us, but T has to be determined by you, the compiler, at compile time in one form or the other, either through an explicit declaration like this or through an inference. Okay. Now those are generic functions. Let's take a look at generic types, because we've got to still be able to define types in Go. It drives everything we're doing, right? The data that we're working with. If you don't understand the data, you don't understand the problem. And so let me show you some syntax where we start to think about types that are going to take on this form of being generic. So on line 11 and on line 18, I've defined two user-defined types. They're named types, vector int and vector string. And you can see that the underlying type of vector int is a slice of int. The underlying type for string is that slice of strings. And I've added some behavior to my vector int and string, which is push. So you can see push takes a value of the vector int. It uses append to add an integer value that we're passing in, and then it returns the modified version of the vector. And again, if we want to operate against strings, I got to define another type. I got to add another method. This one now takes a string. And both of these concrete implementations are leveraging the built-in function append. Now, I just want to state this, right? I said that the func.print functions that we were using before are generic functions thanks to the reflection package. They are. Those print functions can display a value of any type. But Go also has generics in terms of the built-in functions, append, copy, new, make. These are all really generic functions as well. The big difference here is if I keep talking about Go already having generics, especially if I talk about the built-in functions, it's kind of not fair because the generic mechanics that the language developers have to write a function like append or make are really not extended to us, right? So it's easy for me to say, well, Go's got generics. It's just that only the language team gets to use them in the case of these built-in functions, as opposed to we all can leverage the reflect package. But we're leveraging in the implementation of these methods the idea that append is a generic function that can take a slice of some type and a value of some same type and then perform that operation. So really the only difference between vector int and vector string is the fact that I want to work with one specific type of value for this given vector. Now, could I leverage the empty interface like I did before with my vector? I sure can. I mean, I could define my vector as a slice of the empty interface, which would mean that I could store value of any type in this vector. Push doesn't really look different. I mean, look up here on line 21, again, because append is generic function. We're kind of leveraging all of that. And again, the only thing that's changing is the empty interface. However, there is an actual semantic change to this vector interface. Remember, our concrete vector types can only work with that one specific type, ints and strings. And we know what the data is when we're working with those. But when it comes to the vector interface, the semantics are different because I can store ints and strings and floats and anything I want in this vector, right? And there's no guarantee that a value of any given type in any position is anything. So working with this vector interface, though the implementation, one could argue is similar. It's the same couple lines of code. So maybe it's not that hard to maintain and read and understand. Working with this vector will be a lot more difficult than working with the vector of strings. So once again, is there a way to define a vector of some type t to determine a compile time that would allow me to maintain a vector of a single data type and not this mixed data? Well, let's take a look at how we can do that with the new syntax. So once again, let me move this out just once again so we can just see it. Remember what I want to tell the compiler once again. I'd like to define a type named vector generic whose underlying type is a slice of some type t to be determined at compile time, some type t. So again, how do we constantly tell the compiler, hey, t isn't going to be defined by me, it's got to be defined by you? We use our syntax again. We use our square bracket keyword type, and then we lay out those identifiers like this one, t, that has to be determined at compile time. And we can see again that the push method doesn't change, except now we're not working with the empty interface, we're working a value of some type t. And now when we define what the receiver type is, it's not just vector generic, but vector generic of some type t, some type t, some type t. And we have this t all through the declaration. And again, this works because of the nature of append already being a generic function. So you're seeing here that even as we define a name type, who in this case, the underlying part of the type will be determined at compile time. We're using this syntax to tell the compiler, don't expect me to define T, ain't gonna happen. You need to define T. Or at least we have to identify what T is at compile time. Now, let's look at the construction calls of this. Now, if we just start here, right, I'm constructing a value of vector int. I'm calling its push method. I did this all on one line of code to help, with the readability here. And then we can range over those integers and display them. And even though print is that generic function using reflection, I want to be clear here that I'm using percent that the types match, just to show some usability here. So we can say percent %d because I know that every value inside this vector is going to be an int. I could do the same thing here. I can say percent %s because I know every value that we push into this vector has to be a string. It's bound by the concrete type that we used to declare the underlying. When it comes to the vector interface, even though the implementation was relatively the same as the concrete, the usability gets a lot more complex. Look at what I'm doing on line 71. I'm pushing an int, I'm pushing a string, I'm pushing an int, I'm pushing a string. And as I range over this vector, if I want to be explicit about the type of data I'm outputting, I'm back to doing type assertions. And if I don't have a case for a piece of data that I could potentially put in, then I can't even output that value here. So you can see that, again, when we're using the empty interface here, we really change the semantics when we can store different types of data. There's no guarantee what the data is anymore. And now that's causing us to write type assertions to validate what kind of data, what type of data we're operating on any given index position. But if we go back to our generics, well, here we are again. I can now construct a vector generic. And in this case, there's nothing that the compiler can hang on, right, to infer the type. So like you saw me do explicitly with the generic functions, we're going to explicitly during the construction of the generic type tell the compiler here what T is going to be. We're not defining a new type named T. We're telling T that based on the existing types that that you know about, in this particular case, T will be an int or T will be a string. It's being determined here, again, at compile time. And now we can just push integers because we'll get an implementation of push that works with ints. We'll get an implementation of push that works just with strings. And I'm back to knowing, as I iterate over this vector, what the data type is. So we can come in and build this. There it is. You can see I'm mixing data types using my empty interface version. We're back to being able to do explicit types, and we can come back in here again. And I don't have to write any more code for this, right? I can just go ahead and do that and come up with some floating point numbers here. And just say F for this. And you can see here that I'm not writing any more code. I'm just now constructing a vector generic of the float 64 type. If I did everything right, there it is, though I didn't change the labels. But you can see here that we're now operating against floats. Pretty cool, right? Pretty cool. So again, we're back to the idea that I have a vector of that single data type. I don't need the type assertions anymore. I don't need the extra complexity in working with the data. I know what it is. And we can see on the construction call of that name type where we're telling the compiler what that T is going to be. Okay. So at this point, I've shown you both the ability to write that generic function and how we're leveraging the new syntax with the square bracket type T to tell the compiler that T is going to be defined at compile time. I'm showing you now, again, how we're using it this time with a named type, a user-defined type. Okay, excellent. Good. Let's keep moving on here, and we'll get to those questions after. Now, let's get back to our generic functions. The function that I wrote before, which was just outputting values from a given slice, well, that wasn't, I mean, the fact that we could just output any type of data, we were able to write those functions. We didn't have any need for the data to hold what I would call a constraint. There are going to be times where we're writing code and we're going to have to tell the compiler that we can't use just any value for this type T, that we've got to put some constraint on the data that type T could conform to. So the question is, how can we apply constraints to the data to give us that guarantee at compile time that the data we're using for type T does work and won't cause any integrity issues? Well, let's see how the spec handles constraint. Now, to do that, what I'm doing right now is I'm defining two user-defined types. I've got my user type, I've got a customer type, and they both implement a method named string that returns a string. And the implementation of this string method is really creating a pretty print, let's say, in this case, a JSON kind of looking version of each specific type, right? Here you can kind of see a JSON document related to user. You see a JSON document related to customer. I'm using this string method to provide this kind of customized, pretty printing of what a user and a customer is. Okay, great. Now, what if I wanted to write a function that could stringify a user or a customer, leveraging that string behavior? Well, let's look on line 38. Here we are again on line 38. I've got a stringify function that only works with users. It accepts the slice of user. It can construct a new slice of string, range over the collection of users, call the string method for the stringify functionality, and then return that new slice of string. If I wanted to do it again with customers, now again, I need another function that only knows how to work with customers. And if you look at the 5 lines of code that I've written here, once again, they're really identical outside of the fact that we want to work with a user or a customer. But if I have another entity type tomorrow, I need another function. Now, we've talked about this a little bit, so we'll move quicker here. I could leverage the empty to do this once again. I could say I will accept a slice of any type, technically any data. I can do the type assertion again. If I find a slice of user or a slice of customer, I can take those 5 lines of code and apply it. Again, all I've done is converted the functions for each given type into case statements, not really a generic function, but it works for at least the types that I've coded. Then you're right. I can use the reflect package. Look at how much more code is involved here with the reflect package to maintain the high level of integrity. Again, we got to check to see if this is a slice at all. And if it's not, now I'm returning nil. Maybe maybe that's okay. But there it is. We've got to do that. We're going to construct that slice of string of some length. We're going to range. We can't really range over it. We're going to iterate over it. And now I've got extra work to do, right? I know I need to use the string method. So here I am asking the reflect package, does the value at index I even have a method named string? If it's not valid, we got problems. If it's valid, we can call that method, which we need to do to get this the stringified version of, say, users and customers. And then I have to make another string call in order to get this append to work. We went again from 5 lines of code to, I don't even know how many lines of code this is now, right? Over 10, 13, 14. I mean, a lot more code. And again, a lot more complexity. We can go back and say, well, the average developer at most levels could understand the other code I wrote. This requires a lot more work and understanding and digging into the reflect package. But hey, This is it. It's a generic function. This will work. I can pass this a slice of any type, and we will be able to stringify it. Okay. But I'm going to go back again. Can we write a generic version of this function leveraging the concrete implementation, which we know is a much simpler implementation, and avoid the reflection calls? We can. We can. Again, we want to use T to define as some type T. So we go back to our brackets. We go back to defining that T will be defined at compile time. It's not something that we're going to define. We've seen the syntax already. But we have a problem with this code. And the problem is that if I leave it like this, the compiler will have to provide some error information. You see, we are calling a method named string off of each value stored inside that slice of some type T. And right now, the way this code is written, the compiler has no assurance that the value for T will contain this method. We need to tell the compiler that it must constrain T to be of a type where there will be a method named string. Now, today, when we want to apply these types of constraints, we use interfaces, don't we? We define interfaces to apply behavioral constraints so we can write polymorphic functions. And the current draft says, if we're using interfaces today to define that same type of constraint, then we should be able to use interfaces as well to define the constraint. And so what you're seeing me do after the declaration of type T is define the funct.stringer constraint, which is already a constraint defined, or an interface defined by the func package, which says that data must have a method named string that returns a string. I want to stress again that there's nothing novel here, right? I can write a polymorphic function like this that says, I will accept a value of any type, any value, any pointer, as long as that value or pointer has a method named string. We're doing this already. We're writing polymorphic functions in Go with behavioral constraint. We have the same need here. When I have to tell the compilers, I will accept a value for any given type T, but as long as that type T provides the constraint that there will be a method named string. So here we are leveraging the interface in our generic function declarations to be able to tell the compiler that this behavior has to exist. Very much what we're doing today with our polymorphic functions. So if we look at our main application, there's my slice of users, there's my slice of customers. I can pass that slice again across all 4 of the different functions that we wrote. Okay, printing that stuff out. I can come into that folder. I can run this. We see our pretty print versions of users and customers. Now, I'm not going to go ahead and create another type here. We don't have to do that. But I'm going to remove the constraint just so you can see the compiler message associated with it. And you can see here, similar to if we were writing our polymorphic functions, that the compiler is saying, whoa, Bill, you're calling a method named string off of value, and you haven't really bound T to be of a type that would exhibit that behavior. So again, we're going to leverage the interfaces that we have, either new ones or existing ones, to be able to constrain what type T can be based on, in this case, behavior that is absolutely mandatory to exist. Okay, pretty cool, pretty cool, pretty cool. However, sometimes the constraint that has to be applied to the type T isn't behavioral like this. Sometimes it's more based on what I will call properties of the data. Maybe I want to use a plus operator or some sort of double equals operator, right? Equivalent, or we're comparing two things. Not all values can be added together, right? Our struct types can't be added together, and there's no operator overloading in Go. We're not going to be able to implement a plus operator, say for users and customers. But we might have the need of writing functions that maybe just work with the scalar types, and to be able to tell the compiler this has to be restricted to the scalar types because of the type of operations that we're performing. So let's look at how the draft currently gives us the ability to constrain that type, not just on a method set, but maybe also on properties of the data. Now, if you look on line 16 and 17 for a second, I know your eyes are moving to 12, but look at line 16 and 17. I'm writing a function named add, which will take two values of type t to be determined at compile time. We'll add them together and then return a value of type t from the sum. The plus operator is the problem because not all values that I can define, especially those user-defined types, will work in this particular syntax. So once again, we need to be able to define constraint. And so in this particular case, the constraint isn't on behavior because this isn't behavior driven. It's not operator plus behavior. It really has to be constrained on the type of data that we're going to allow. So the current draft right now has this as the current suggested syntax for defining constraints, where we have to limit it to a particular set of types. And you can see that it is a type list defined inside the scope of the interface itself. And so what we're doing here is telling the compiler, look, the only types that T is allowed to be at compile time will be types that belong to this list. And so now we're guaranteeing that data that's passed into add for V1 and V2 can operate and work with the plus operator here. Now, with that being said, this is one area of the current spec that is still under investigation. It's an area of the spec that many people are very, very iffy on, right? Because this is really kind of new. Everything else I'm shown you, I would say, still looks and feels like Go. Maybe this is the first time we're starting to deviate a little bit. It is a problem we need to solve. The other problem with this syntax, at least for today, is that we can't use an interface like this with our traditional polymorphic functions. This won't compile. Currently, at least with the draft, if I were to write a function that said, give me a value of, pass me any data of any value as long as it conforms to the add only, right now the compiler says, I'm sorry, you can't use this interface because it's declared with a type list. And that's not really very Go-ish either, right? I mean, one of the beautiful things about Go is that when we do something like this, we don't lose that backwards compatibility. We don't lose our ability to use it. So this is an area of the spec that is, we need it. The question is, where does this end up landing, or what does this look like in a year? And the Go team is very, very interested in your thoughts and ideas here. You know, maybe we keep the type list, but we also use it to write polymorphic functions like this, where we restrict the type. Maybe this gets pulled out, and there's another way to do this type of constraint at the point that we're declaring T to be a generic type. I don't have any answers. The language team is currently looking at options here, and they've told me that this is something that they're not 100% happy with. This is a current draft implementation to solve this problem, and they would love your feedback and thoughts in this area. So as part of the survey, this is an area that maybe you can express some thoughts or ideas or talk to them directly. We'll talk about that at the end of the talk. But this is what we have right now to defy that constraint. So we know that we're only using types that can work today with that plus operator. Okay. Let me show you something else. There are some pre-declared constraints in the draft as well. This one here called comparable. And if you notice, I'm writing a function called index, which takes a slice of some type t and a value of that same type t, and we can range over the collection looking if that value of type t matches the find. And if it does, I return an index position. We're doing another linear traversal, but remember on line 29, we can only work with data that can be used in this, right? In this if statement. If I allowed myself to pass in a slice of a slice, we'd have big problems. I can't compare two slices like that. So this, the language team is experimenting with, are there any kind of pre-declared type constraints that maybe we can provide where developers don't have to implement their own type constraints here or own interfaces to support this kind of maybe operation. So here the language team is also really interested about, do you like this? Do you not? Are there others that we could potentially provide? Or is that over, all of that. Okay, so you can see that. Now, another thing I want to show you here is, and I'm not going to go through this example, but I just want to show you this, that you're not restricted from having interfaces that could mix both that type list and behavior. Now, I haven't found a very good practical reason to do this. But what's interesting about this example here is the need for the interface to also leverage a generic type T. And this is kind of what I want to show you. I wanted to write a function called match that took that slice of some type T and a value of type T. But in this particular case, I want T to be constrained where it has a match method that takes a value of type T and returns true or false. And so in the declaration of match for matcher, I want T to be a type to be determined at compile time. So here we are again, telling the compiler, let's define an interface called matcher, where T will be determined at compile time, and then is the value to be passed in to the method match to be defined by T in this call. Now, I don't really need to restrict this match function to just person and food. So don't look at this as, oh, Bill had to do this. No, I don't really. The real constraint is here on the call to match. But like I said, I haven't found a practical reason to do this. And maybe a year from now, what we find is that there's just no reason for this. And maybe that somehow takes care of what we're looking at today as potential confusion. I don't know. So these are areas of the spec as you're looking at code you've written, projects you have, work at code, where if you find a real practical need to combine both type lists and methods, behavioral like that, together, where there was no way around it, the constraint had to be both, I am super interested because I haven't found it yet. And it might very much be that we don't ever need this. Like if we're doing it, we're kind of forcing it. And that might solve some of the other problems. So again, I wanted to show you this. And you can see I can run this code, okay? If I comment out all of this for a second, we just go back to the add. The add here works with integers, strings, and floats. Okay, integer strings and floats. And if I come back up to the add and I remove the string, let's say, now the compiler complains, hey, Bill, string isn't in that list. So as soon as we define a type list, that's it. I mean, you're going to be bound to those types. Now, Go will respect the underlying type. So if the underlying type is a scalar type, then that will match the list as well. Okay. We can comment that out, and we can see the rest of this. But for the time we have, I'm going to leave this for something that you can explore here. Okay, there's a lot of code here. It's not terribly important, other than the fact that I'm restricting right now matcher to be person and food, and I really don't have to. Okay, very, very cool. It's 2:06. I started I've got like almost 4 minutes left for my hour, and there's 2 more things I need to show you. So let me get 5 and 6 out of the way here. Let me show you these syntax choices here, because again, there's choices that you need to consider and we need feedback on in terms of the draft. And then I'll get to questions, and then we can share some comments. Now, all number 5 is doing is showing that a type list can be of multiple types. So let me just get rid of this for a second. You're not bound to the type list just being of one type T in this case. Notice I'm saying in this function that we're going to have 2 types to determine at compile time, one of type L, one named V, where L is a list of labels and V is a list of values, right? So I want you to understand that you're not bound to just one type. This could be a multi-type list. Again, L and V being names to be determined at compile time. But if you noticed, I'm using a method off of V. So we're back to the constraint issue of telling the compiler that whatever value, whatever type we use for V, it has to be a type where we can guarantee the data has a string method. Okay, good. Now, as part of the syntax, what I want to show you is that when you have a multi-type list and one type requires a constraint, they all need a constraint. However, I don't want to constrain L. So you might see code as you're going through examples where in the type list, you see the use of the empty interface as a constraint. Just know that because I had to apply a constraint here, the current implementation says all types need a constraint, and therefore the empty interface is that way of constraining without constraining. Now, maybe in a future release, the compiler is smart enough to be able to just ignore the need of having a constraint everywhere. But as you continue to work or play with this, I want you to appreciate this. I ran into this problem, assuming that this would work, and it doesn't. Compiler will tell you V isn't constrained. So we have that. Okay. Let me show you the last example here, because it focuses on 2 things. One, on 0 value returns, which is an area of the spec that I don't know if it's important or not. I'm going to show you the options. And it gives us something that's maybe a little bit more practical, and maybe something I don't even want you to do. This is a scary little example here. Now, one of the things that I'm really, I don't want to say against, one of the things I tried to teach people away from is defining interfaces for an entity, because these types of interfaces aren't really generic interfaces. They're not interfaces that can be reused. I have a strong belief system that an interface defines behavior, and hopefully reusable behavior. And when I see people defining interfaces for a user or a customer, you start seeing interfaces that are very, very specific. They're not reusable, and I think they create a big mess. Now, don't get me wrong. There's interfaces in the standard library today called con, net.con. It represents a network. It has 4 or 5 methods associated with the interface. It's not necessarily reusable beyond network connections. But it serves a really strong purpose of abstracting the network connection, right? Russ Cox is introducing in a new draft design a file system interface. Again, it's not highly generic. It's focused on file systems, and it's an entity-based interface. And I feel like these types of interfaces, when we're talking about data input, networks, file systems, devices, maybe that's where we can get away with these types of interfaces that are more entity-based than, let's say, behavioral-based. But with all of that being said, let's just take a look at a little bit of code here. Again, I don't necessarily think I want people doing this, but it did allow me to share cases where the zero value could show up. So look what I've done here. I've defined a type named user, and I've written a function called insert user. Now, what insert user does is it takes a SQL point, it takes a database connection, takes a user value. It has the query we need specific for users. It executes that. It then gets the last ID from that insert and applies it to the user value and then returns a user value that's complete. I like value semantic mutation for these types of things, right? I got a user value without an ID. I return a new user value with the ID. I think there's a lot of integrity writing these types of functions. We've got the intelligence of how to insert a user in here. And if there's failure anywhere along the way, we return a zero value user and the error, right? Or we return the new user and nil. And we're taught to use zero value construction, like literal construction on these returns for readability. Now, if I wanted to do the same thing with a customer, I would pretty much copy and paste a lot of the same code. If you think about it, the only thing that changed between insert user and insert customer was the query. I mean, this is specific to a customer. The customer has certain fields. We're changing out the type, but execute query is kind of already a generic function because of reflection. Last insert ID returns the int 64, so it's kind of generic in that. But I want to be able to set the ID, so I have to work with a customer or I have to work with a user. So looking at this, I asked myself, is there a way to make this more generic without writing an interface, okay, at an entity level where I write an interface like this? These are things that I don't want to do. I've had a bad history of these types of interfaces, right? Where somebody calls this an entity so they can write generic functions based on this behavior. This isn't reusable. This isn't a reusable interface. It's not a behavioral driven interface, right? It's an entity based kind of interface, right? And so I just want to clearly say that I'm not a fan of this. I definitely don't want to do this. I try to teach against it, but this is an approach a lot of people take, right? If we want to write a generic insert function, then I can use an interface like don't do this that says implement a query, implement args, implement a setter, which is already a big red flag for me. And then I can write a generic function that's basically built around the behavior that I've defined that an entity needs in order to do this generically. And what really hurts me here is that this is already a generic function, and this is technically already generic in the fact that it's always going to be a 64. And I've done all of this work. I've added a new type. I'm making everybody write these methods for users and customers. I mean, I've added a lot more code to this product to be able to satisfy this function, to make this simpler, primarily all for this, all because I want to set the ID. So the question then is, can I write a generic function that does an insert without this extra interface so I could set the ID and then everything is good? Actually, with the current draft, we can. Now, because the current draft isn't fully implemented, and I'll show you where, this code won't compile, but it's absolutely legal based on what the draft is saying. So look at my insert function here. Insert takes the database connection, takes an entity of some type T, like a user or a customer, then it takes the query and the arguments. Now, that I had to move out because, again, I don't want an interface that returns queries and arguments. I can apply them. Okay, so maybe the API changes a little bit. But this does also return a value of type T, which is what I want. Type T in, new type T out. Now, I can pass the query and the arguments to execute. I can get the last ID. Now, here's the thing. I find this really interesting. I think this really helps to eliminate a whole bunch of code bloat here. The spec says that if I define a set of types that have, in this case, this ID field, well, the compiler can identify that. In other words, I don't have to write a set function. I don't have to write a set method. I don't have to bind myself to that. I can use the concrete value entity of some type T and access its field set. As long as I tell the compiler that all values of type T must have a field named ID. And I can do that here. So if I add another entity, and we don't add a lot of entities over time, so this isn't a big lift, compiler would tell us we forgot to add another entity here. But by defining this entities interface, I would be able to just access the ID field directly, and I wouldn't have to write these interfaces like this to try to make things generic. And the funny thing is that you're trying to do this, so you only have to write this boilerplate code once, but you're asking everybody to write 3 methods for every entity. You end up with a lot more code at the end of the day. Where here, we have our generic function. I'm not asking anyone to write extra methods. And the type list gives us access to the ID field directly. And we're much closer to the original function. Now, remember, this function's returning a value of type T. And I want to be able to return the 0 value. So there's 2 ways to do that in the spec. One way is this. We use the built-in function new, we construct a value of whatever type T is, and we dereference it. That will give you 0 value. The other way is to declare a variable named, in this case, 0 of type T. We know that will construct a value to its 0 value state. And then you use 0 on the returns. I like that better, personally. I think it's more readable. But I meet people who like the idea that they don't have to construct another variable somewhere to do that. And there are some people who prefer, we'll just do the construction next to the return and not create this kind of variable at the top of the function. You've got these 3 choices. But it's only going to come up when you are writing functions that will return values of type T. And right now, I've only kind of seen that in some functions where we were using the empty interface as the return type. But this is an interesting kind of example I've shared with you because I think it could potentially be a way of reducing things back down to boilerplate without creating these types of interfaces that I think add more harm than good to a code base over time, personally. So it's something to think about here, something to think about for sure. But I really love the idea of being able to access a field in a generic way, as opposed to everything being just, say, method-based, right? Instead of being method-based. Okay, and you can see how that generic function could be used for an insert user call, right? Define the query, I call my generic insert. So really simplify a lot of complexity potentially by doing this. Okay, that is all I have time for, and I have, at least at this point, shared with you the core syntax aspects of the draft. The rest of the examples are there for you to look at more practical examples and to explore things. So with that being said, what I'd like to do is go ahead and try to answer some questions. So even if you've written a question in the chat, what I would prefer, and if it's okay with the meetup organizers, is just unmute your mic and ask that question, and then I'll do my best to answer it. And then I'd like to maybe open the floor to some comments as well. But I would first prefer to answer some questions around the syntax and things I've shown. All right, I don't know if the organizers are.
Yeah, it's absolutely fine. So I see the question from Vokial. Maybe you can ask this question, or you have some issues with the mic. Otherwise, we will just read it, because I'm just looking for the questions, and the first question is from Vokial. I don't know how to spell it out. The Deaf Knight.
Well,
so the question.
There's a question above that about using the angle brackets.
No. There's before. Sorry, Bill. There's one question before the.
Hear me?
Yeah.
Okay. So hello, everyone. Thank you for the great presentation. My question is about the cost of generics. If there are any, I don't know, when you, for example, in Go, it's not like in C. When you're defining something, then the compiler will decide, will it go to the heap, will it stay on the stack? When you're using the interface, it's more straightforward. And I wonder what kind of, maybe indirection the generics will introduce.
So I want you to think of it this way. What the compiler is doing is essentially defining and constructing that concrete type on the fly for you, right? For your program. So this doesn't really change anything related to escape analysis, but I will argue that there are, if you can, okay, let me say it this way. Anytime you store value inside of an interface, it's an automatic allocation because there are flaws in the escape analysis algorithm, and that value can't be tracked anymore. If you're using closures, interfaces, it's an automatic allocation. So we close the door on that. Now, when you're using concrete data directly, you now leave the door open to reduce an allocation. Because if the value being constructed doesn't have to be shared beyond the bounds of the function it's being constructed in, right? So the way I think of it is, any function that constructs a value owns the value. If the value doesn't have to exist after the function returns, it gets to stay on the stack. If the value has to exist after the function returns, it has to go to the heap because the function's gone, its stack space is gone. So those same rules will apply to your generic types. Now, there could be possibilities now where there are allocations because you're using the empty interface, and we now get rid of them because you're using concrete types. But it's not a blanket, we're reducing allocations. We still have to look at how a value is shared down the call path, up and down the call path to make that final decision. So all I'm going to say to you is that there is potential opportunity to reduce allocations with generics, which could potentially provide a little bit more performance because maybe some less GC. But it's not automatic, it's not guaranteed.
Okay, thank you.
Wojtek, you're muted right now.
Yeah, next question.
Oh, sorry. I was muted for a moment. I was so excited. Okay, so the next question is about using different symbols to indicate generics. So in Java and C# we have this greater than and smaller than for generics. And one of the users is asking why we are going with the with a different approach.
I'm going to bring up a blog post I just published on that first example, because everybody asks this question. I laid it out in the blog post, and I think it's best to just show it there, okay? It is just not feasible to use the less than greater than angle brackets in Go because it's going to break backwards compatibility with the language. So let me show you something. So this is what you're asking. Why use square brackets and not use the less than greater than that you see in both C, C++ and Java, okay? This is what it would look like. Here's the problem. Look at this code that I have here, all right? This code actually builds and runs. If I were to take this code here, we go into the Go playground, regular Go playground, and I put it in here and we format it, and we run it. This code works. If you notice that Go is allowing me to define multiple variables on the same line of the assignment. And when Go looks at this syntax, what it's really doing, right? Essentially, what it's doing, it's currently breaking that down to represent this, right? There it is. There we are. So that's the problem, because if we were to use this for generics, then if you look in listing 15, the compiler now has huge ambiguity. Does this statement mean this? Or now are we invoking a generic function where X and Y are types defined, not necessarily in this source code file, but in some other source code file that I haven't gotten to yet? The compiler is so focused on performance that it doesn't really have the ability to do these look-aheads. And so to maintain the backwards compatibility of the language, maintain the performance of the compiler, it's just not possible. It's really off the table. Now, the square brackets, however, are really not a problem. I mean, because there are other languages. I think Scala is one of them. There's another programming language named D that's using the square brackets. And so Go isn't setting a precedent there either. But I just want you to understand that if it was an option, it would be in the spec. It's just not an option where we get to maintain backwards compatibility. And Go is so focused on this that I would even be shocked if we ever actually saw a Go 2.0 that kind of split the language in half. I mean, it's possible, but I would be shocked.
Nice, thank you. There's another question from Daniel. Daniel, I cannot hear you, so please try again.
Can you hear me now?
Awesome, yes. Please
yeah.
go.
Okay, so I have a question. Let's say we have function which takes generic type of T, and we call this function with strings and with integers. So in C++, compiler will generate two variants of this function, and program will be bigger than you write some function for one type. So how does it look in Golang?
My understanding is that it's the same thing that's going to happen. We're going to have an int and a string version, and yep, that there's going to be code there. I mean, in this particular case, that's probably insignificant. But one thing that you do have to remember is that the reflection package also has to be 100% supported. So yes, your programs are going to get a little larger because not only do those implementations have to be built out, but all the metadata for the reflection package also has to be built out and supported. I just don't know any way around that.
Thank you.
Guys, any other questions?
Yeah, hi. Nice presentation. I like to ask you, because this opens a huge Pandora box for any other implementation, because I feel like Go with generics will suddenly become language that we can create streams, iterators for types of all different types of frameworks, like persistent frameworks and all that stuff. And that will bring a lot of additional complexity to the language space and the library space. And what about that? I feel like Go without the generics is simple and easy to write and read. And introducing this um, reusability in that way will definitely help framework authors, because they will not need to rely on code generation, for example, but will hit regular developers, in my mind.
It is an absolutely fair question. It's the question that's on everybody's mind. So if I answer it, I'm going to be giving you my opinions on it, okay? I think there is real value in having this version of generics that we're talking about in Go. I don't know if the rest of what you saw under the omissions is warranted, and I think it's going to take a lot of debate to see much more in the short term. Now, why do I think this version of generics, which in my presentation, I'm really showing you how to remove the use of the empty interface, right? Why do I think this adds value to the language? Think about being able to have a package in Go that could implement a lot of the concurrency patterns that we're all writing ourselves today with channels and fan outs and fan ins and pooling. I think there's a lot of bad code out there today where people are implementing their own concurrency patterns and being able to have a generic type T can eliminate a large amount of concurrency bugs day one by having that in the standard library. So I'm very excited about that. And one of my examples, I think it might be 10, I started playing around with what could code around concurrency look like with, say, channels of some type T. So I think there's huge wins there to reduce a lot of concurrency bugs and complexity that I see. The context package in Go is used everywhere, right? For timeouts and for data gathering. And that's using a generic value bag today with the empty interface, which requires a lot of typecasting and does open you up to, at runtime, suddenly identifying that some data is not in there and it should be. And I think one area I'd like to see this generics being worked is having a generic context type. I think that can eliminate some complexity and some potential bugs in software as well. And then you've got the sync package today, which has a generic map and pool type, which have been engineered to deal with cache coherency problems around the mutex use and cache lines, but it has to use the empty interface. So I'm not saying that the empty interface, not using the empty interface there is going to give us better performance, because you're going to have allocations there probably anyway, but it does reduce the need to do the type assertions again. And so I think there's big wins today by reducing the use of the empty interfaces in places where we're stuck. Now, that being said, are people going to come in and start building really large frameworks like we see in the enterprise today? Absolutely. But that's no different than what I see today with people writing large object-oriented design programs in Go. I see that, unfortunately, quite a bit. And we could argue that, well, you know, we shouldn't be doing that. No, but people always take what they know first before they can learn the better ways of doing it. So for me, what I'm hoping is the following over the next year. One, I've asked the Go team that they are not to release generics until they have proper amount of documentation on design philosophy, guidelines, and example programs where it should be used and where it shouldn't be used. And we have, let's say, a year to have that. I want them to set the ground floor for everybody else who's teaching this in the do's and the don'ts. I think we as a community over the next year need to figure out also what are the best idioms, as well as the guidelines, like should we use capital letter T as opposed to more names, depending if it's a collection, a return type, something like that. And I think that anybody who's asking me this question, like you are on the front line. So when that person on your project wants to use generics, you have the responsibility to say, whoa, 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 can we do it without? Because if we can, then let's not introduce it. And we've got to tell people and teach people to be able to say no when they know that it can be done in a more traditional way. So we have a huge amount of education over the next year to get to, with a big onus on that being the Go team. Now, if we don't have all of this and we release, I'm going to be as nervous as the next person. But if we could put all of this in place, then I think we're going to be in really great shape. Think about how many people abuse channels their first year, and how many people a year later turn around and go, I'm ripping all this out, right? I am praying that by the time this gets released, we don't have that. The people already know, let's not abuse it, because now I'm going to tell you this, okay? Why is Bill out here teaching generics and kind of promoting to get this into the language in a year from now? Why is Bill doing this, right? Understand something. I don't keep this a secret from anybody. I run a consulting contracting shop. My revenue is based on companies hiring me and my team to work on projects. Therefore, my revenue is based on growth. And which companies end up paying the most and more for developers and training? The enterprise. And the language team has heard over the last 10 years that a lot of these enterprise shops can't use Go because they can't build, unfortunately, the frameworks that we are afraid they're going to build. But they need, let's not see the word need. They feel they need this. And I'm not sure this first version of generics gives them everything. But if more big companies, the enterprise companies, ones that are even, let's say, really focused on Microsoft's cloud, the John Deeres of the world, right? If they actually now are able to move into this language because of these changes, it helps everybody. It helps the language. It helps you. It helps me. It creates another 1 million developers. It creates more use. And so the question is this balance for me on, yeah, I know that there's potential harm here. So we have to really focus on education. But if we bring in another 1 million developers and another 500 companies of that size to start using the language, then there's huge wins for everybody here. So I'd rather be out here up front right now, teaching syntax, trying to show it, trying to help with defining what this is. So when the enterprise comes in, they won't make really crazy mistakes. And people like you and me can come in and say, whoa, 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 slow down. What are you doing? You don't really need this here, okay? So I want you to think of both sides of the coin, because we can't have both. And I think both are important.
Thanks. I really like your opinion on that.
Guys, we have some time to take 1 or 2 more questions, so don't be shy.
All right, so let me do this as well while we're waiting. I'm going to copy, I can't copy that. Hold on. I'm not sharing my screen. Let me get these links again while I'm waiting. Now, I spent a lot of time showing you the syntax. And, oh, wait, I sent that to just one person. I hate Zoom chatting. Here we go. I spent some time really trying to show you the syntax and the need for that type list, right? To tell the compiler that T isn't going to be defined by you, but has to be defined at compile time in one way or the other. So what I would love everybody to do is go back through the rest of the examples I have and try to get some general sense of the code and the syntax and where it can be applied. And then go back through your projects, whether they're personal ones or at work, and look at places where you're using the empty interface today. Look at places where you had to define that, what I'm going to call that entity-based interface to make something generic. And look at how could generics help reduce the amount of code I'm writing today can reduce the amount of complexity in these cases, and experiment with it. And then if you want to talk to the language team directly, you send me an email. I'll share with them directly the things that you've come up with. The survey is an opportunity for you to share thoughts in an anonymous way. But I've told the language team, not all of us like to be on the mailing list. Not all of us like to participate on the Go issues lists. There's all this crazy debate that goes on. And I'm one that doesn't like getting into the debate. I don't enjoy it. And what I'm offering you is an opportunity for you to share your thoughts directly to those that are working on this without it having to become this public domain thing. Or if you want to do it anonymously, that's what the survey is for. And don't really have to answer today. Spend a couple of weeks, spend a month, whenever it is. We've got at least a year before this gets really serious in terms of maybe being in 118 or 119. And I'll add my email here as well.
So, Bill, I have one question. Probably you answered this question. I have a feeling you answered this question. The Golang, the generics in Golang was a taboo topic for such a long time. What did happen that it came back to the mainstream discussion? Because I remember a year from now, there was some people pushing generics, but then there was big pushback from the Golang team. What happened during the last year?
What everybody doesn't realize is that the language team is about 50 people. And they have enough work for about 300. And they only do a release every 6 months with patches, basically, security fixes in between. If they really needed, if we really wanted to make a dent over the last, it took the last 5 years to get where we're at because the team's so small. And everything that we have up till now has been more important than the generics, all the performance improvements. Look at all the inlining and now the new scheduler that's preemptive techniques and all the performance improvements just over the last 3 years alone. And it's taken 5 years to get there because the team is small and they're just not going to be able to get the head count. So if they had 300 people over the last 5 years, we would have been talking about this 2 years ago, but they don't. And the language now is finally at a point where this topic 10 years in with where we're at is now something that is important, that it's now at the top of the list. And again, it's an important feature for the enterprise. It's an important feature for those developers and those companies that are not part of the Go community yet. And if we're, and it comes down to do we want growth in the language or not? Maybe there are people who say, I don't want growth, so let's not do it. But the decision is really around being able to grow the language and bring in more developers and more companies using it. But again, that's why this isn't one release of generics. This is going to be many releases, just like the scheduler has changed, just like garbage collection has changed a lot over time, right? Generics is going to change a lot over time. But for me, these are the core reasons we're talking about it now. We're finally at a point where we can actually focus on it.
Thank you. So I think we can take one more question.
One more question I have, maybe.
I don't work for Go. I don't work for Google, and I'm not on the Go team. So when I say we, I'm talking the community. All right. Sorry.
I thought about the alternative for like generics, and I would like to ask you if and why did you not look at that? And maybe I thought that maybe if we had like types that we can compose with each other. So you show the example of user and customer, and both of them has ID field. And if we can somehow specify like something that we have identifiable or identifier type, and then both user and customer would just compose of that type. And directly composed, I mean just merging that inside of them, so embedding that type. And the result would be that if you write the function insert something, you will just be, you can return the value of identifier. So you don't know if you have a user or customer, but you only use the fields that you would need. I think that will be in, I think, in the parallel of the interfaces that are currently are in, and the ability of Go that it will just compose types on the fly from those interfaces. So the same for like fields.
Yeah, I hear you. I totally hear you. Here's one problem. I'm using the word problem, but the Go team is pretty focused on making sure that there is a strong general use case for something, right? So I found this use case where I think having access to a field instead of building a whole, what I would call bad interface, adds value. But maybe this is the only place that it's viable, which means, do we want to introduce that into the generics proposal for this one use case that happens 0.5% of the time in all code bases, right? That's the other problem here as well. But I like the idea that a field could be a constraint as much as, but I think that's what the type name is doing, don't you? By putting user and customer. What you're saying is, Bill, if I define a type called ID and I embed that in user and customer, then in the type list, I only have to say ID, and the compilers should be able to do that. And I agree, the compiler should be able to do that because it can do that with underlying types, right? It could see that this was a slice of string and only has to conform to string. My question then is, do we really want to be writing types we're embedding for fields like that? I don't know. That opens up a whole nother can of worms, right? Where I teach very much, no, give every type their own ID field. Let's not use embedding as a way of handling inheritance in a sense. So that might open up a whole different can of worms that we don't want, instead of just adding. But these are the problems, right? We have to.
I thought about some fluent solution, like for example, you can, of course, and you should embed type ID field in every type you use, but of course you can do the same thing as I said. So you just specify type ID, and compiler could like derive on the fly that this type is like this super set of that type, and if it is super type of that type, it can be used in those places, and then let user just return this type and use this type directly. So
yeah, I think it's worth exploring for sure. And we have the next year to explore these ideas. But these ideas don't present themselves until you're working and you're trying to solve a problem and seeing if generics makes the code easier and cleaner, right? But I think it's worth exploring. I never thought about it. So it's definitely something I need to think about more. But I like it. I like the idea. For sure, I like the idea. I just don't, I hate those entity-based interfaces. I hate them. I think that's very OOP. It's very much code bloat. They work when they start talking about networks and file systems and these lower level devices. They work really well down there. When we start talking about business types of entities, I think this is where things become a mess. And we should be really focused on reusable types of interfaces based on readers and writers and closers and things like that. So yeah, maybe generics fits here. But yeah, I like the idea.
Okay, guys. Bill, thank you a lot for your talk. And guys, you can find the email to Bill in our chat. I will also post on the meetup.com all the links to the presentation, to the proposal, and you can also find it on our GitHub page. And I would encourage you to, raise your voice in the discussion, because I think it's quite important discussion. And I'm really looking forward to find out what will be the final solution. Now we are having this kind of 15 minutes or 10 minutes for you guys. If you're looking for somebody for your project or for your company, please speak out. Please share it with us now.